In the first part of our journey into the world of data and databases, we explored the basics of files, data, and databases. In this video, we'll delve into database normalization and learn how join operations are used to combine data from multiple tables. Let's dive in. Imagine you want to store a person's details, including their personal information, communication preferences, and security details. While it might be tempting to store everything in a single table for easy access, this can lead to redundancy and potential data integrity issues. For instance, if a customer's name changes, you'd have to update it in every entry. Missing just one update could lead to bad data. To address this problem, we use normalization. Normalization involves organizing data into multiple tables to minimize redundancy, enhance data integrity, and safeguard sensitive information. For example, you wouldn't want to store payment details or social security numbers in the same table as other customer information that is more widely accessible. For illustration, let's split customer information into two tables, a customer table and a contact table, where the contact table holds phone numbers. To establish relationships between these tables, we use a common field, typically a primary key in one table that acts as a foreign key in the other. In our example, the customer ID, the primary key in the customer table, is stored as cust_ID in the contact table. In databases, there are three main types of relationships between tables. 1. One-to-one and a one-to-one relationship. One instance of one entity can relate to only one instances of the other entity. For example, if a person can have only one passport. 2. One-to-many. In a one-to-many relationship, one instance of one entity can relate to multiple instances of the other entity. Consider if it is possible for a person to hold multiple passports from different countries. 3. Many-to-many. In a many-to-many relationship, one instance of one entity can relate to multiple instances of another entity, and simultaneously, one instance of that second entity can relate to multiple instances of the first entity. To represent this relationship, an additional table, often referred to as a junction or associative table, is needed. This juncture table typically contains foreign keys that reference the primary keys of the two related entities, creating two one-to-many relationships pointing to the same table. A common example of a many-to-many relationship is between students and courses. In this scenario, a student can enroll in multiple courses, and each course can have multiple students enrolled in it. You can represent a many-to-many relationship with two one-to-many relationships that point to the same intermediate table. Let's revisit our customer and contact tables. We split the information into two tables for better organization. But how do we view the data together? That's where joins come in. A join is a way to combine data from two or more tables in a database based on a related column between them. There are three main types of joins. 1. Cross-join. 2. Inner join. 3. Outer join. Let's dive deeper into each one. Cross-join. It pairs every single row from one table with every single row from another. It's usually not what you want, unless you're looking for a complete mess. Inner join. This is like a matchmaker. It only shows you the rows where there's a connection between the two tables. You will only see customers with contacts. Outer joins. These are like detectives. They find all the information, even if there's a missing piece. There are three main types of outer joins. 1. Left join. Shows all customers, even if they don't have contacts. It fills in with empty information for contacts that don't exist. 2. Right join. Shows all contacts, even if they don't belong to a customer, filling in with empty information for customers. 3. Full join. Combines both left and right joins, showing all customers and all contacts, filling in with empty information where there are no matches. MySQL doesn't support full join, but it can be achieved using union on left and right join. With a solid understanding of joins, you're ready to tackle more complex database queries. Join us next time as we dive into advanced topics and explore even more exciting database concepts. Thanks for watching, and see you next time.